Jumping into Bluebook number 4, Math Module 2, the hard one. Let's get into number 1. We have 55 students and whether they want to enroll in this new program. Of those, 20% of the 55, they said do intend to enroll, and then that would just mean the other 80% of our 55 do not want to enroll. What's the best estimate of the ones who do intend to enroll? So that's just going to be 0.2 times 55, or 2 times 5.5, which gets us 11 of the 55. Look at number 2 here. We got a machine makes large boxes or small boxes. I'm looking at my equations down below for a total of 700 minutes. So we see our 700 for each of them. It takes the machine 10 minutes to make a large box. Okay, so 10 for large and 5 minutes for the small. And not only that, it gives us variables. So it says for the large boxes, we see X, and for the small boxes, we see Y. So I should see a 10X, a 5Y, and we see that right here, 10X, 5Y for a total of 700 minutes. It's going to be B for this one. Looking up at number 3, we're going to not be able to see all our answers here, but let's see what we got. I see that we have a scatter plot between X and Y and a line of best fit. Which of the following represents the best line of fit? So it looks like we're going to have about a positive 13 y-intercept. So I see A and B. We're going to get rid of these two. And then I also see that it is a negative slope. So we can go ahead and get rid of A. It's going to be B because we have a positive y-intercept, negative slope, B here. Getting into number 4 here, we have another function. I see we have the points when X is D, Y is 4, lies on the line. What is the value of D? So again, for these ones, I'm always just plugging this into Desmos. It looks like we have the point when our X is 0, we're at 7. And when the X is 8, we are at 0. So I go ahead and open up my Desmos here. And we add a table. And we go ahead and plot 0, 7, and 8, 0. And we go ahead and graph that. And our equation is this. So then all you have to really do is copy this. We can say, okay, f of x is equal to that. So what would f of... Actually, no, instead of that, we can just say when our x, or when our y is equal to 4. And then you can kind of see this intersection point over here. It's going to be whatever this is for our x. So let's go ahead and type in some of these fractions here. 26 over 7. Does that get us there? No, it's a little bit different. What about 24 over 7? And I think that's exactly it. Okay, so our answer is going to be C here. So these ones, you never want to try to guess. It kind of looked like it might have been 3.5, but it is a little bit different. Plug in your line, get your function, get your exact decimal. Let's go ahead and check out number 5 here. Shift this over. Okay, so number 5, very similar. I see another table, but this is going to be a little bit different. I see that we have an x squared, so you always want to check the power of your x. Let's shift this down real quick so I can type my points in. And it looks like our points are going to be, so new table, -1, 10, 0, 14. So for when your line is linear, when it's just an x to the power of 1, we only need 2 points. When it is an exponential or a quadratic, we do need 3 points. And we want to change this linear regression here to quadratic. You can see it does turn into a parabola. You can see the 3 points line up. And our equation is going to be 1x squared plus 5x. So I shift this over, and it looks like it's going to be letter choice D. So again, that's all we have to do for these. Just plug your function and get your exact equation. And we're going to go with D here. Not too bad. Looking down at number 6, let's see what we got. F of x is equal to this. F of a is equal to 10. Okay, so again, I'm going to plug this into Desmos as well. We're going to try to do as much on Desmos as we can to minimize our mistakes. So again, the function, I'm just going to type it in here, but it was f of x is equal to x plus 15. I'm going to do this little parenthesis trick. Oh, it doesn't work when you do f of x, but usually you can put a parenthesis there and just do the right side. Divided by 5, there's our function. And they said our y is 10 when the x is a. So all we have to do, let's kind of bring this up now. All we got to do is shift over to when these intersect again. So you'll notice that I'm using a lot of these like x equals, y equals. When our y is 10, we hit 35 for x. So again, if I get rid of our Desmos here, you'll see That's going to be our answer here. It's going to be C here. A lot of those y equals x equals to get intersection points on our Desmos. Getting into number 7 here, one of our favorite graphs, we have x is equal to y. And then again, I could put z up here, and I could say z plus x is equal to 180. So they say we have an x equation, we have a y equation. I'm just jumping to Desmos. I'm going to have Desmos do all my algebra for me. So again, our equations were 6k plus 13, that was equal to x. And I can set it equal to y, which was 8k minus 29. But again, we don't need to use a slider here. We already know that there is a solution to k here, so we just replace it with an x. And you can see on our Desmos, they tell us that x or k is equal to 21. So I jump back. K is equal to 21. And then they say, what is the value of z? Jump back to Desmos, because we already kind of summarized what this equation would be. It would be 180 minus our x value. So our x was 6 times 21, and then plus 13, and that's just going to get us 41. So this is just really how to use Desmos to do all our algebra for us. Zero room for mistakes. So we would just get C for this one. Looking up at number 8, let's get rid of this. We have an equation, line R is perpendicular to line P. So all we want to do is put this in y-intercept form, or slope-intercept form. So we would just have 2y is equal to negative 18x plus 9, divide everything by 2. Y is equal to negative 9x plus 4.5. And finally, line R is perpendicular, so it's going to be 1/9. It's always 2 changes. Flip your fraction, flip your sign. It's going to be C here. Looking at number 9, this one's highlighted, so it's going to be a little bit more interesting. A sample of oak has a density. Remember, we don't need to know any equations for this. They have to give it to us. So as I'm reading these kind of more complicated ones, I'm transcribing it. I'm translating it as I read. So we have, it has a density of. So our density is going to be 807 kilograms per cubic meter. So that's going to be 1 meter to the third. And let's see what other information they give us here. They tell us that the sample is in the shape of a cube, where the edge length is 0.9 meters. So I'm always trying to think parallel, symmetrical, matching. So as soon as I see a length, okay, well, I do know that 0.9 meters to match the other equation they gave us, it's going to go there. But again, they started with meters cubed. They gave us a length. Just to confirm, they do want the mass in kilograms. So we're kind of staying in this density format. So I don't want a length, I want volume. So all you have to do is if you cube that 0.9 meters, so if I would just go, okay, 0.9 meters cubed, we should get, it's like 0.729 meters cubed, 0.729 meters cubed. So again, it looks like it's a little bit smaller than this, than our, our starting fraction here. And then you also just have to think, well, what should happen to our numerator? And again, it's going to decrease. To keep these fractions equivalent, because our density isn't changing, it's the same material, just a smaller amount. You multiplied this by 0.729 to get 0.729. So you would multiply this by 0.729 as well. And you should get something really close to A here. You're going to get 588. Because it keeps our fraction the same, and that's going to be kilograms. So really nice little problem. Just organize your fractions, keep your units matched, or you have to change them, sometimes cube them to keep your units the same. Down here at number 10, we have a lot of highlighted ones now, so this is where it starts to get good. So this one, a lot of people kind of get correct because of a coincidence. Because, and I almost do wish they would have maybe changed this. You see this 4%. They say by n%, and a lot of people just go, oh, well, it's 4. But this isn't actually true at all, right? Because our exponent is not 1. So this is a 290 start, 4% increase when we just have a t as our exponent. With it being a 4 over 6t, we actually don't know how this exponential function functions yet. Our 290 is still going to be our start, but our 1.04 is not accurate. So let's just see what kind of change they want first, right? They say that they don't even want it per year. They want it every 12 or every 18 months. Well, right now we have a t, and our t is in years. So we have to try to make this connection between years and months. Well, if when t is 1, that would be 12 months. What about when it's 18 months? So to go from 18 months to years, it's going to be 1.5 years. So if they want 18 months, but we're starting with a t, which the unit is years, that's actually going to turn into 46 times, again, our t would be 1.5 to go to 18 months. And that actually just cancels out. If you do 46 times 1.5, that actually gets you your 1 as your exponent. So you can just say, oh, it is 1.04. So your increase is going to be this 4% every 18 months. Kind of a coincidence. I do wish they'd maybe change that one, but that's how it turns out. Number 11 here. Let's see what we got. Okay, so again, I always want to identify, categorize what type of problem am I dealing with. I see that we have 2 linear lines, and I see that there's no solution. That's all. This is a no solution 2 linear lines system. That means that I want to see both of my lines in slope-intercept form, and I know that their slopes are going to be equal to each other. This is also a little bit of another role, and that is if I ever see parentheses, I want to distribute the side that has the parentheses, and then I can set my coefficients equal. So this is actually 2k x minus 2n. And then now I can set these equal. I can say, okay, I know that my slopes are going to be equal to each other. So I know 2k is going to be equal to negative 28 over 15. And I would divide both sides by 2. Divide by 2. This just gets a 2 in the denominator since there's already a fraction. 2's go away. This is negative 28 over 30, or negative 14 over 15. So yeah, not too bad. That's going to be the value of k to make these 2 lines parallel to each other, same slope. And looking up at number 12, little percentage one. Let's see what's happening. So they buy them for $7 and they resell them at 290% of. Really focus on those percentages. Of is the percent you see, so that's where I would just multiply. I don't know this one off the top of my head. 2.9 times 7. Oops. 2.9 times 7. So that's going to get us to $20.30. When it is not of, you'll see increased by 290% or 290% more. That's where you have to add a 1. That's where instead of timesing by 2.9, that's where it would turn into a 3.9. But again, we'll see more examples of that on future problems. So they are selling these at $20.30, but there's a discount that is 80% off. Just remember that 80% off means you're retaining 20% of the value. So let's do 0.2 times 20.3, and that's going to be $4.06. So honestly, not too bad of a problem. Looking at number 13, I see a function with c. I'm jumping straight to Desmos. Let's go ahead and unhide this. And let's shift it down so we can see. Okay. So again, our function is going to be x to the second minus 34x plus c. Add our slider. We don't like including the equal 0 because look what changes. So right now I see this is a parabola. I gotta zoom out a little bit more. You can see it's a parabola, right? So if I do equal 0, what it does is it turns it into parallel lines because these are just my 2 solutions to the function. I promise you, this is a good habit to build. I'd rather see a parabola than 2 parallel lines. But let's see what they want. This system has no real solutions. Pause there, don't read the rest. Our goal for these is always going to be, we want to get our vertex up to the x-axis. So as you can see, as I slide this, it's not going anywhere. I'm going to crank this up to 100 for each of the parameters. Let's see if we can get a little bit more movement here. So as I go this way, it gets further away. As I go this way, you can see it's starting to move upward. So I'm going to really move this one up. And I can get this just around the x-axis. As soon as you can see it's close to the x-axis, I can see 290 is really close. You make it both of your parameters close to that number. So I go maybe up 5 and I maybe go down 5. And what this does, it allows me to zoom in, and then now I can go really gently over and back and forth across the x-axis. So some values that I would want here are, I want to know when I'm on the x-axis, because that's going to be how many solutions? 1. So I know that when c is equal to 289, this is just good practice. We would have one solution. If we jump back, we could maybe test, and I'll just stick with integers here. When we go to 290, that's going to be no intersections. So I'll just write this in the background. When c is equal to 290, that is no solutions. And then finally, if we go across, and again, stick with an integer, 288, c is equal to 288, we have two solutions. Okay, let's hide Desmos. So again, here's our three main points that they'll ever ask for. We have all three values. In this case, they want no real solutions. So we want when c is equal to 290. And again, if we jump back to Desmos, when we go to no real solutions, as you can see, like c gets bigger. So like the smallest we could get is 290 if we're sticking with integers, and it just gets bigger. So do we want the biggest c? Do we want the smallest c? So they say, what is the least possible? So they want to minimize n. And again, if n is less than c, the smaller c is, the better. So this is where it gets a little weird. If I say c is equal to 290, you might say, well, n can just be less than c, so I can make n 1. I can make it 0. Not the case, because an inequality works both ways. If I made, say, n 1 here, this inequality is telling me that c just has to be greater than n, so that means c could be 2. We are forced, 290 is the smallest that c can get. So the next lowest that I could get for n, since n is less than c, is going to be 289. So just try to remember that. Try to stick with your integers and try to stick with just like going one more to the left or to the right. It's always going to be correct here. So 289 for n. If I look down at number 14, this is another kind of classic one. You'll want to build a good habit with this. When you see, well, let's just go through it. So we have data set A, and it has 75 buildings that have a mean of 32. You can already see I'm starting to organize this in a way, and we'll kind of talk about it. Data set B has 50 buildings that have a mean of 62. So why am I writing them like this? What this tells you, let's just get what these totals are real quick. So we have 75 times 32, and that's going to be 2,400. And then we have 50 times 62, and that's going to be 3,100. So what happens is when they say we have a data set C that consists of all of these buildings, right? It's going to be 125 buildings. And they're wondering what that mean is of these 125 buildings. So I think the trick here is a lot of people would just take the two means. They'll take 32 plus 62, divide by 2. The reason why that's not how simple the mean is because how many of each matters, right? If you have 1,000 buildings that are 32 meters and one building that's 62 meters, then you don't just add those two and divide by 2. Your mean's going to be much, much closer to the 1,000 buildings than to the 1. So to account for how many total buildings there are, you get your total height from A, your total height from B. So that's going to be what, 5,500? And then you do your total height, 5,500, divided by how many buildings are in this new data set, 125. And what you get is your mean would be 44. So again, I think you would have got 47 the other way. It's only slightly different because the amount of buildings is like kind of close. But this is how you always do means and total number of buildings. Get your total heights, combine, divide by total buildings. Looking down at number 15, this one's always an interesting one, but we want to try to follow some of the rules that we've used. So I see we have this expression can be rewritten as, that's a classic, rewritten as just means equal to a parenthesis form. As soon as I see a parenthesis form, the other form was standard form. We want to distribute the parenthesis form so I can set my coefficients equal. So let's start. We got hx squared plus hjx plus kx plus kj. So now I can set my coefficients equal to each other. It's distributed. The easy one is 4, right? H is going to be 4. B is always going to be a weird one here. B is going to be equal to hj plus k. And remember, the reason I'm doing that is because I'm just factoring an x out of this. I'm factoring an x out of that. So there's just going to be a b left and an hj plus k down below. And then we have our coefficient at the end, negative 45, is going to be equal to kj. Okay, so again, your middle one's always going to be your most confusing. My strategy here, honestly, would be to try to do the easiest answers first. Are there any answers that are just purely coefficients, numbers? So again, they want everything here is an integer, and one of the following is also an integer. So again, I see B, I don't want to do yet because it's this more complicated equation. I look at C, well look, H we already know. That's just 45 over 4. That's going to get us a decimal, not an integer. And then again, D also has a number, 45 over K. But K is either we choose the K that's wrapped up in this middle one, or we can look at this K that's here. K times J is negative 45. Well, K and J are both integers. So you kind of have to ask yourself, well, what are some possible values for what K and J are? And what you'll learn is K and J are just going to be factors of negative 45. If K is 1, J is going to be negative 45. Right? If this is 5, this is going to be negative 9. You are trapped because they're integers into K and J just being two different factors of negative 45. So once you kind of prove that, you say, well, 45 over any factor of negative 45, even if it becomes negative, it's always going to get us an integer. So not too bad there. Very good one. Looking up at number 16, let's see what we got. So it looks like another, systematic one. They love doing these. We have a parabola. We have a line. I'm going to get these both up on Desmos real quick. Let's move this up. And on Desmos, let's do our line first. Y is equal to negative 1.5. And we have x to the second plus 8x plus a. We don't know what a is yet. And I zoom out here. So remember that when there's two lines drawn, we do not care about the x-axis anymore. Any type of solution, 1, 0, or 2, is going to be when this line intersects our parabola. So specifically, they say one distinct solution. So just remember, that's going to be when we hit the vertex. So I say, okay, what if we did 20? And let's try to figure out really accurately here. This one, we probably don't have to change much to get it there. It looks like it's going to be when a is equal to 14.5. So I get rid of my Desmos real quick. Let's make sure there's no tricks here. Nope. A is going to be 14.5. And then again, if they ask for two solutions, you would just go a little bit more down so the parabola hits it twice, or you would go a little bit further up with the the line would have to be below it for 0 solutions, above the vertex for 2 solutions. Not too bad. Down to 17. I always love these problems. Probably a little standard deviation. Oh no, this one's just median and range. Okay. So we have 15 values in this table. Dataset B is created by adding 56 to each of these. So all they're doing is that would become what? 77, 78, 79, 80, and 81. I think I'm off by 1 on all of those. So that's 81. This is going to be 80, 79, and 78. So not too bad. That's just a 1 right there. That's going to be our new data plot. That's going to be B over there. And let's see kind of what differences they want to note. Which of the following compares the medians and ranges? So range is always easy. You just go 22 to 26, which is going to be 4. Same thing. I could go 78 to 82. That's just going to be 4. Let's find out which ones say range is equal to each other. Range is equal. Range is different. Range is equal. And range is different. Okay, so now we just want to figure out our median here. So our median, when you have data points like this, it's pretty easy. You just go, okay, cross off an extreme, cross off an extreme. Let's cross off 2 here, cross off 2 here, cross off another 2, and 1. Our median's going to fall to a nice 23. Since these are symmetrical, our median for the other one's going to be 79. So I look for dataset B is equal, not going to be the case. The median of B is greater. Looks like it's going to be C here. Decent problem. Let's get rid of some of this for our next one here. Number 18, another very good problem. So we have a graph here. Unfortunately, when I do see these graphs, I always like to plug in points to Desmos. For some reason, Desmos really struggles with this graph. If it's any other function, if it's exponential, quadratic, linear, it's going to be able to plot these 3 points and give you a function. For some reason, and we can kind of see what type of function it is, like a 1 over x, it just doesn't do it. So we got to do this one a little bit more by hand. They tell us that this is our function. So there are other ways too, like a little bit of shortcuts, like you can look at your answers. You can see that they're only doing a translation of 4, right, in your horizontal direction. So I know my parent function is going to be the same, but let's just ensure we're getting our correct function for this. It's really not that bad. All I have to do is plug in 2 points to my equation, and I can get my original function. This up here, they say is f. These down here are g. So in these ones where you have an f and a g, figure out your f first, then you can figure out how it's changed to become g. So again, we have our y. So let's try the points, -6 and -3. And then let's try -6. Oh, that's going to be -5 and -6. -5 and -6. Okay, so my 2 equations are just going to be -3 is equal to a over -6 plus b. And then my second equation is just going to be -6 is equal to a over -5 plus b. What's cool is Desmos is just going to do this very quickly for us. So if I pull up my Desmos real quick, I don't know if I'll be able to move this one far enough away. Yeah, I can throw it over here actually. So over here, we're going to type in our 2 functions, but notice what I do here. -3 is equal to x divided by, is that going to work if I do it like that? It does. -6 plus y. The reason I'm doing this is because I don't want to have to do any algebra. I want the Desmos to do the algebra for me. So I use x and y for my a and b, divided by -5 plus y. I found out when those two intersect each other, and it looks like my x is 6 and my y is 4. So let's just figure that out on paper here. So 6, 4 just means that my a is 6 and my b is 4. So my actual equation is down to my answers, as they do like to kind of do. This is going to be my f. So again, not too bad to solve for that using Desmos. They want g though, and they're saying that g is just when we plug in. Remember, this used to be f of x, but now we're replacing our x with x plus 4. So you do the same thing. 6 over, you're substituting x plus 4 in for x, and then plus 4. So that just equals 6 over x plus 8. Not too crazy. It looks like our actual g of x function is going to be c. B was f of x. Not too bad using a combination of Desmos and math. Jumping down to number 19. This is another very good one. Let's try to shift this up a little bit. Okay, number 19. So I see that we have a quadratic, but it's like very advanced. There's a b, there's an a. The product of solutions. Okay, so we're going to have 2 nice little equations to use here. Whenever you see product of solutions, it's going to be your c over your a when they're in standard form. If it's ever the sum of your solutions, it's going to be -b over a when they're in your standard form. So again, this is product. So I already know the product of these solutions is going to be c over a. So that's going to be ab over 57. They also say the product of the solutions is this. So this is their classic. We have an equation, a formula, some way to figure out our own product of solutions, and they give us a product of solutions. You set these equal to each other. AB, divide both sides by AB. Remember that there was a 1 up here, so your k is 1 over 57. This problem is extremely brutal to solve otherwise, so really try to make some note cards of these little equations. C over a for product of solutions, -b over a for sum of solutions. Looking down at number 20. Gonna have to scroll up a little bit here. Okay, so we got number 20 here, and they want the graph is a circle. We jump straight to Desmos. Open up Desmos here, x to the second plus x plus, oh, let's pull this up too. There you go. Plus y to the second plus y is equal to 199 divided by 2. So you think this one's super easy. You just plug in the circle. it can actually be a little bit of an illusion. The way to always nail your circle in Desmos problems, click anywhere on your circle. Notice how you have all these points show up. It's always going to show your axes points. We don't care about those. Do you notice this weird top and bottom point that aren't on any other axes? These are always going to show up. They are your true top and bottom. They represent your diameter of your circle. So now that we know that, our x isn't moving, we're traveling from negative 10.5 to positive 9.5. So try to think from negative 10.5 to 0 is 10.5. Then you travel an additional 9.5. You've traveled 20 total. So I jump back to this and I say my diameter is equal to 20. They want to know radius, divided by 2, we get 10. Almost done. We got 2 more problems left here. Let's go ahead and shift this over. And up to 21. Oh man, this is another one. Okay. So we got a rectangular prism. So let's just get an idea of what that looks like. Square. Well, they do say the base is a square. So I draw 2 squares. I draw my prism the best I can. Looks something like that. Pretend those 2 are connected. And we have a height of 90. So I just make that the long side here. Let's get a different color in here too. And they say the base is a square. So I think as soon as I see that the base is a square, they don't give us any other numbers, anything to represent. So I say, okay, we know this is x by x since it's a square. And they say the surface area of each, so of one prism, is k. So this is another example. They give us a surface area. We have to develop our own surface area. So that's just going to be x squared for this face, but there's 2 of them. So that's 2x squared. And then this is the weird one. It's going to be our x times 90, and there's 4 of those. So plus 360x. That is going to be equal to k. So got our surface area of one prism. Of course, they're going to make it a little bit more complicated. They say, hey, what if we glued 2 of these together along the square base? So I'll try my best to draw this maybe down here. So they glued these 2 together now. Now they look like this. And all the dimensions are that, like, we still have x for the square base. We still have 90 for our height of each. So now they say the surface area of this obviously is more. If this is 1k, this is 92 over 47k. So this is still 90. That's still x. So to get the surface area of this, we still have 2 of these. So that's going to be 2x squared. But then this part's going to change. It is now 180 by x, and we have 4 of them. So I think that's 720. So plus 720x, and that's equal to 92 over 47k. And again, good luck if you like doing this stuff by hand. I'm going to plug this into Desmos, but we got to kind of, we got to use some fail safes here because this one is a weird one to use in Desmos. I'll show Desmos. I'll try to type it in where you can see. Yeah, I think it works like this. So look, if I type in my 2x to the second plus 360x is equal to, maybe we would try y, right? Because k, if we put k in, it would be a slider, but k is already a defined value, so we don't want a slider for it. And I think you're going to see this, it doesn't work this way, but I just want to be in your shoes. I want us to be able to like kind of fail safe this. So equals 92 over 47 y. So when you see this and you're like, this obviously isn't working, it's actually not too crazy. Look at this. This equation up here is equal to y, and we have a y right here. So y, what's stopping me from just going, okay, get rid of this, replace this with that. And now this is just an x function. We are really comfortable with x functions, and it looks like our 2 solutions are 0 and 8. I jump back to my problem, and 8 is fortunately an answer here, and that is the answer. So again, not too bad. Be able to work through those kind of fail safes like, why didn't it work this way? Let's try another way to use Desmos. It worked that way. Finally, number 22. I see we have a vertex at 9, -14, and it intersects the x-axis at 2 points. So remember that means our A has to be greater than 0 because we're below the x-axis, and for it to intersect it, it has to be upwards. They give us this standard form, and all they tell us is they want to know what these 3 could be added together. So very wide open. We want to know when to and when not to use Desmos. I would say Desmos in this one's very hard because it's too open-ended. We don't know what we can slide A, B, or C to. A, we just know has to be greater than 0, so it can be any decimal. Also, it's hard to make our sliders match a parabola to just a vertex. It's very unrestricted. There's another version of this problem where they give you 2 x-intercepts instead. You can imagine it's much easier, you're much more restricted to use your sliders to hit 2 x-intercepts than you are to just hit one vertex. So when you come into these, think, how restricted is it? If it's much more restricted, try Desmos. If it's really open-ended like this, let's try it by hand. There is a shortcut here, but we'll try that after. I want to make sure you always know how to do this. So if we have a vertex, let's try vertex form. That's going to be A times x minus 9 squared, and then minus 14. And then we got to expand. That's just going to be A times x squared minus 18x plus 81. And then again, minus 14. And the final is ax squared minus 18ax plus 81a minus 14. So remember, all we've done is we've created an alternative version of our first equation. So one way to write it is that standard form. Another way to write this equation is this vertex form that we've created. So these equations are equal to each other. That's going to really help us because, again, our goal is A plus B plus C. So our A and our A is the same in both. So if I'm creating this sum, I would say A plus. And then our B is always going to be the term that's in front of X. So up there it's B, but down here it's negative 18A. Well, I'd rather keep my letters the same. So I can replace that B with plus a negative 18A. And then finally, my constant, my C, is just going to be my constant in this equation. That's going to be plus 81A minus 14. If I combine all my like terms, we should get 64A minus 14. So that's my new sum, much nicer. But still, what can we do here? If this is my new sum, I need it to be equal to one of my answers here. So you'll actually find this not too bad. We can just set this equal to my answers, right? I can say, okay, well, what if this is equal to negative 23? And when I add the 14 over, I'm still going to have a negative. When I divide by 64, my A is going to be a negative number. Don't forget that first restriction, that A has to be greater than 0. So this isn't going to work because negative 14, when I add it to both sides, it's not going to cancel out. Not going to work. This is going to get us 0, which would give us no solutions, right? And then finally, negative 12. Look what happens when we use negative 12, which is less, or rather can get canceled out by when we add 14 to both sides. So I add 14 to both sides and we get 64A is going to be equal to positive 2, divide by 64, and then you can see how crazy this decimal would have been in Desmos. So our answer choice is D here. We've proven it by hand. The little shortcut that sometimes we'll see, hopefully a lot of times we'll see, is, well, what if we tried when x is equal to 1? Like if we said, well, f of 1 is going to be equal to A plus B plus C. And then you have to think, well, what possible values could there be for f of 1, right? The most negative that we can get on this parabola, it's an upward facing parabola, the most negative we can get is our vertex. So all of my, no matter what x values I plug in, as long as my x value is not 9, it's going to be less than negative 14. So that's kind of like your little bit of a shortcut. You actually know that it can only be negative 12 here. When x is 9, we get negative 14. When x is anything other than 9, it's going to be less, or rather greater than negative 14. And our only answer choice for that is going to be D. A little bit of a shortcut. Always try that like f of 1, see if there's a little shortcut like that. If not, we know how to do it by hand. And that's it for number 22.